In this video, we'll introduce compound interest. Now in the previous chapters, we looked at simple interest, but now we're moving to the next level and focusing on something called compound interest. Compound interest is where you have the interest added to the principal every time it's compounded. And we'll demonstrate that in the examples that we have here in lesson 13.1. So we're going to dive right into this. In example 1, we are looking to find a compound amount. We're looking to find the interest using compound interest. We're looking to find simple interest, the difference between the two, and then also in the word problem it talks about a goal. So in this example here, we have a couple, Tony and Lynn, need $8,000 for a down payment on a house. They have $5,500 and they invest according to 5% per year compounded annually. Now we need to find the information about all this that they provide us. So they're looking to purchase a house, and the principal that they have is they have $5,500. They're looking to have a rate of 5%, and the time is over 4 years. So we're going to use our formula, which is located right up here. We know equals principal 1 plus I parentheses exponent, which is shift 6, and n, which is our time. Enter. So over a period of 4 years, at this rate, at this principal amount, it would be $6,685. Now for part 2, they want us to find what is the amount of interest that was earned. So we're going to use our maturity value, which we just found here. We're going to use our principal, and we're going to calculate compound interest. So we're going to equals compound amount minus principal, enter. Now they want us to do a comparison of simple interest. So we're using the same percents, the same time, but this time we're using the simple interest formula, which is principal times rate times time. So as we see, we'd have 1,100. Now what would be the difference between the two of $1,185.28 and simple interest of 1,100? We'd find that compound interest would bring in $85.28 more than simple interest would. Now, the goal was $8,000. They would not be able to raise that in time. So, the difference between the two would be $8,000 minus the future amount, and they would be $1,314.72 short. So in this example, we're able to use the compound interest formula to be able to calculate this. Example 2 is not on here for a reason. What it demonstrates there is splitting the interest rates and the times that things are compounded, and we'll explain that more in example 3. So in example 3, what we have going on here is an investor has $2,500 in account paying 6% compounded semi-annually for 5 years. We need to find the future amount, compound interest, and the amount by which simple interest calculations underestimates the compound. So let's take a look at that. So this investor has $2,500. They are given a 6% rate compounded semi-annually. Now we're using 3%, and here's why. Whenever something throughout the year, whenever it's compounded, we divide it by that amount. So throughout the year, we have, in the first example, we had things being compounded annually, which is once a year. Semi-annually is twice a year, quarterly is 4, and then monthly is obviously 12. So what we do with the rates when things are compounded more than once throughout the year, we divide that interest rate divided by the amount that is compounded. So this example says compounded semi-annually. So we take the 6%, we divide it by 2 because semi, twice throughout a year, we get 3%. Now let's look at our time. The time we're going to put in here is going to be 10. Now, instead of dividing the time by the times it's compounded, we're actually counting the amount of times it's going to compound throughout a year. So it's 5 years. That means it's going to compound every 6 months because it's semi-annually, which means that's going to be 10 compound periods throughout 5 years. So with rates, we divide the amount of the times being compounded, divide by the percent. For the time, we multiply it. So that's why we get the 3%, which is 6% semi-annually, and 5 years compounded semi-annually. We get those numbers there. So now we're ready to find our simple interest. So principal times rate times time. We get 7,500. Now let's do this using our compound formula. So 2,500, 3% rate, and 10. All right, so we're going to take principal times parentheses 1 plus I and N. So 3,359.79. They want us to find the compound amount minus the principal. So we're taking 359.79. Oops. We're taking the principal, which is 2,500, and we're going to find the amount of interest that accumulated. So compound amount minus principal, we'd add 859.79. Now, what is the difference between the two and the amount of interest that was earned? Compound interest was 859, simple interest was 750, and the difference between the two, when we take compound interest minus simple interest, is $109.79. All right, moving on to example 4. Now, for this lesson in the book, it wants us to go to the back of the book to locate our different percents, and then it would be able to provide us the nominal rate. Instead of flipping through the book, we can calculate that ourselves. So for this first part of the example 4, they give us 4%, and they say that there is 12 compound periods. Now, all we need to do to calculate this is we're taking the back half of the formula. So equals parentheses 1 plus I exponent n. And by doing this, this is our nominal rate. For the second example, they give us 8% compounded 27 times, and they want to find the nominal rate. We go equals parentheses 1 plus I exponent n. So now, if we were to take these rates and multiply it by a principal, we'd be able to find the maturity value using compound interest. So that's all these two are asking for. They want us to find the nominal rate. Instead of using the book, we are using the spreadsheet to calculate this out. Now, example 5, we have a person called John. He inherits $15,000, and he was looking at putting it into a retirement account, compounded semi-annually. He is given 25 years, and he's hoping that he'll at least get 6%, 8%, or 10%. So what they want us to find for John is what is the compound amount for all three of these. So the amount he inherited was $15,000. So that's going to be the same across the board. The rate they give us is 6%, 8%, and 10%. So as we discussed in example 3, it says here in the terms that it's compounded semi-annually. So we're going to take that interest rate and divide it in half. So for this first example, we're using 6%, so it's semi-annual, it'd be 3%. For this next one, it's 8% semi-annual, so it's going to be 4%. And the last example is 10% semi-annual, which is going to be 5%. All right, now we're going to look at the time. The time is 25. So Since it's semi-annual, like we mentioned in example 3, we multiply the time given by the times it's going to compound. Since it's semi-annual, that's twice a year. So that means there's going to be 50 periods throughout the next 25 years that this amount is going to compound. All right, now that we have all the information in order to find the compound amount, let's go ahead and do that. So we're going to go equals principal times parentheses 1 plus I parentheses exponent n, and theirs would be the amount for this example for this one. Let's try the next one. Let's go principal 1 plus I parentheses exponent n 106. And the last one, 15,001 plus I exponent n. Okay, so there's the three examples examples of three different amounts. So as you can see, the more the rate goes up, obviously you're going to get more, the more it compounds the same thing. All right, moving on to example 6. In example 6, it says Ben is comparing two different investment options. The compound amount on deposit $8,000 for 3 years, 6% compounded quarterly, or 6% compounded monthly. So we are given here, we're looking to invest $8,000 for both of these examples. The first rate that is given is 6% compounded quarterly. So, compounded quarterly, that means 4 times throughout the year it's going to compound. We're given 6% for the first example, so we take 6% divided by 4, and we get 1.5%. For the other one, they give us 6% compounded monthly. So if we take 6% divided by 12 times throughout a year, 12 months, we would be 0.5%. Now, when working with a spreadsheet, you have to put a 0 in first if you have a percent that's less than 1. Because if you don't, and you just put 0.5, it'll mess up your formula. So make sure you put that 0 in there first. Okay, now we look at the time. It's 3 years for the first one, compounded quarterly. That's going to be 12 because it's going to compound 4 times throughout 1 year. 4 times 3 is 12. The other one is monthly. So we're going to take the 3 times 12 and get 36 because it's compounding monthly 12 times throughout a year. All right, let's plug in our formulas. So we have principal times parentheses 1 plus I exponent n. And the other one is principal 1 plus I exponent n. All right, so as we can see here, we have the same amount of principal, the same amount of time. Now, whenever anything is compounded, that interest earned over that time of that compound period is added to the principal. So the more you compound, the higher amount your principal is going to increase. So as we can see here, it would be more beneficial for this person, for Ben, to invest with a 12% or with 12 compounding monthly versus compounding quarterly. All right, let's look at example 7. In example 7, we're looking to find the effective inflation on real estate investment. So, Bill and Joy purchased a home $167,200. The house increased by 3%, find its value at the end of 4 years. All right, so we have a house value here of $167,200. We also find a 3% rate, and the time is over 4 years. Let's compound this out. and we'd find the value of this house to be $188,185.07. All right, last example, finding the effective rate of interest. So this one says James is comparing two loans. Loan A, nominal rate at 10% compounded quarterly. Loan B, 9% compounded monthly. Find the effective rate of interest for each loan. So we're looking for the effective rate, the rate that's actually being used for the loan itself. So we're given a 2.5% rate. We're given a time. It's compounded quarterly. So we take that 10% divided by 4. That's how we get the 2.5. And then we have our rates. It's going to be 4 because quarterly throughout 1 year. And we're going to subtract 1, and I'll explain what that is in a minute here. The second example, we are doing 10%, but this time, or 9%, and this one's compounded monthly. So we're going to go 9% divided by 12, we'd have 0.75%. Again, since it's below 1, we have to add that 0 in front of it. So I need to change the cell out real quick to have a percent in here. So 0.75. Okay, it's throughout 1 year, so it's 12 periods throughout the year. We're subtracting 1 to find the effective rate of interest. All right, let's go ahead and calculate this out. So let's go equals, parentheses, 1 plus I, parentheses, exponent n minus 1. Let's do the next for this next one. We're going to go equals 1 plus I exponent n minus 1. And let me fix this other one here. It didn't seem to do the formula quite right, but let's check it real quick. So we're doing, that's what the problem is. This should be 2.5% because it's 10% quarterly. We divide that 10 by 4, we get 2.5 each. So now this is accurate. So now this is our effective rate of interest. We subtract the 1 because if we didn't, we'd have a percent that's higher above than what it's actually supposed to be. So by doing this, we could use this rate to actually find the exact amount of interest that's being used. So in this video again, we covered about compound interest and how that works and how to use compounded semi-annually, quarterly, and monthly. So all of these examples you'll be able to find in your book. Let me know if there's any questions.